Alrighty, so today we're learning about kites and trapezoids, which are just two other types of quadrilaterals that are different from parallelograms. So if we start off with kites, kites are going to have two pairs of consecutive, so next to each other, congruent sides, but the opposite sides are not congruent. So like this side cannot be congruent to this side, but the two next to each other can be, or are by definition, I guess. So we have two congruent sides that are consecutive. So I guess I should have said consecutive there. Consecutive. And definitely not opposite congruent. Okay, because if they were opposite congruent, that would be a parallelogram. Here are two main properties for kites. So the diagonals are perpendicular, and we have one pair, exactly one pair of opposite angles that are congruent. So whenever we have a kite, these angles right here, okay, the ones that are in between the two sides that are not congruent, are going to end up being congruent to each other. And then 100% not allowed for the other two. So they'll be completely different from each other. So only one pair of congruent angles. So if we're doing this one here, I don't know how well this shows up on screen, that angle's 124, this one's 80. We know that these two will be the same because they are going between the two sides that are not congruent. Okay, so the two sides that are not congruent are going to end up having congruent angles. And in a quadrilateral, four-sided shape, we know that the angles add up to 360. So we can do 124 plus 80 plus the two x's, and that has to equal 360. And I was not prepared enough to have a calculator up and running. So let me try that real quick. So I'm just subtracting the 124 and the 80 to the other side. That's going to give us 156 equals 2x, divide by 2, and we get that x will equal 78. So the measure of angle D, which we labeled as x, is going to equal 78 degrees. You should pause the video and try this one on your own. I'm just going to go right through it. So in the kite, the measures of the angles are blah, 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 blah. Find the value of x, and then what are the measure of the angles that are congruent? So basically this 3x is going to either equal 75, 90, or 120. So we do the same exact thing, 3x plus 75 plus 90 plus 120 has to add to 360. When we subtract all those things over, we're going to get that 3x equals 75, so x equals 25. And then because 3x equals 75, those are the angles that are congruent. So there we go, done. Easy peasy, lemon squeezy. All right, next is trapezoids. Trapezoids have exactly one parallel side, okay? We call those parallel sides the bases, and then the things that connect them are referred to as legs. There are base angles, which are those two, which aren't necessarily congruent to each other, and these two, which aren't necessarily congruent to each other. And if we want to show that something is a trapezoid, all we have to do is show that exactly one set of sides is parallel, but not both, because if it was both, it'd be a parallelogram. So that just means we need to find the slopes of all of these lines. So if we do slope of OR and slope of RS and slope of ST and then slope of OT. So those are all of our different things here. First one has a slope of undefined because it's vertical. Vertical always has a slope of undefined. Then we're going to have positive 1/2, negative 1, and then positive 1/2 again. So these two are parallel and the other two are not. So we have exactly one. Did I spell exactly? I have no idea. Exactly one set of parallel lines, sides. I should say sides. So that means that this is a trapezoid. So that's just how we show it. It's kind of easy. It's pretty straightforward. It's the same way we show that something's a trapezoid, or sorry, a parallelogram, because we just find all of the slopes. And then in this case, only two of them are parallel instead of opposites. So two sets being parallel, like a parallelogram would have. This question says that we're taking S and we're moving it to a new spot. And what we want to do is say what type of quadrilateral it is now. Okay, so if we move S to that point, what we want to do is just start off with the slopes again. So we'll do slope of OR, which has not changed. It's still undefined. The slope of RS has changed, potentially. It's now up 1, 2, and over 1, 2, 3, 4. So it's 2/4, but that's going to reduce to 1/2, so the slope didn't actually change much. Then we have the slope of ST is now also undefined because it's now vertical, right? Vertical. And the slope of OT hasn't changed. It's been 1/2 this whole time. So now we have two sets of parallel. So this is definitely a parallelogram. And we actually also know that it's not a rectangle. Because remember, rectangles are parallelograms, so we have to be as specific as possible. And the reason we know it's not a rectangle is because the slopes of 1/2 and undefined are not opposite reciprocals. A slope of 0 would be an opposite reciprocal to undefined, and a slope of -2 would be an opposite reciprocal to 1/2. So we know it's definitely not a rectangle. And now we just have to show that it's not a rhombus by checking the distances. So I'm going to find the length of OR, and I'm literally just going to count. So it's 1, 2, 3. Literally just counted how many spaces it is. And now for the length of RS, I'm going to use my unreduced slopes that were over here, the 2 and the 4, because that's the change in my X and the change in my Y. And this is going to be like the square root of 20, and that's definitely not 3, so this is not a rhombus either, because I don't need to bother checking anything else, because a rhombus would have 4 congruent sides, and I just showed that 2 of them are not. So parallelogram is going to be our most specific answer that we can have this time around. And I just want to remind you that on a test or a quiz, I'm much more likely to say, like we did here, show that this is a trapezoid, or show that it's a rhombus, or show that it's a rectangle, and not leave it very open-ended like this, where you have to check everything. I'll be much more focused on a test or a quiz. So now we get to a special case of trapezoids called isosceles trapezoids. So just like in triangles, isosceles means that there's two congruent sides. So in an isosceles trapezoid, the two legs are congruent to each other. And when that happens, there's a bunch of properties. So the first is that the base angles in an isosceles trapezoid are congruent. So before they weren't necessarily. If it's isosceles, they 100% are. So A and D congruent, B and C congruent. This middle one is basically just the opposite. So this one right here is the opposite of that one. It says that if you know the angles happen to be congruent, then you actually automatically know it's an isosceles trapezoid. And the last one down here just says that the diagonals are congruent, which is just like rectangles, okay? So if it's isosceles trapezoid, and only if it's isosceles trapezoid, in terms of trapezoids, diagonals will be congruent. So if we just read this thing, it says if EG and FH. So if the two diagonals are equal to each other, is it isosceles? And we could just say yes, because of that reason right there. A trapezoid is isosceles if and only if its diagonals are congruent. So kind of a silly question. We just draw an arrow to the part right above it. Now it's a little less silly. We got to think about some things here. It says if HEF is this one right here, is 70, and then FGH is 110. Do we have enough info to tell us that this trapezoid is isosceles? So we know that if the two base angles are congruent, and the two base angles up top are congruent, then it would be isosceles. So we need to show that F is 70 and H is 110. And that's not actually super hard to do, because we have parallel lines here, and we have like a little transversal right here, and we know that in these things, these two angles, the 70 and that one right there, they have to add up to 180. And that's this angle right here. And so 70 plus 110 would add up to 180. We can do a super similar process for the other side. So we already have that this is 110 right here. And we know that the 110 and this new red dot that I just put there, that those are also same side interior, so they have to add up to 180. So that means that we know that this angle will be 70. And so base angles are congruent, which means that this is isosceles. Okie dokie artichoke. All right, last thing we have going on here is mid-segments of trapezoids. So just like triangles where we had connecting the midpoints, and we knew they were midpoints, so they cut these sides in half. Whenever we had this situation, whatever this side length was, this was always 2 times as much. And we could write that backwards if we wanted to as well, which is if we knew this was x, this one would always be half as big as x. So midsegments in trapezoids are the same exact idea. A midsegment is only one of them. So unlike triangles that had 3 of them, there's one midsegment, which is going to connect to the 2 legs, okay? And it's going to be parallel to the bases. And it also has this neat property right here that I'm going to summarize in words. So basically, the midsegment is equal to 1/2 the length of the base plus the base. So that's the length of this base plus this base. Do half of that, and that will equal the midsegment. Okay. So we're going to skip this example because it stinks. It's the worst thing in the world, and I don't like it. So we're going to skip it, and we're just going to do this one, and you'll see that this is not super crazy hard. So to find the length of MN, I'm just going to do 1/2 the length of the base, 12, plus the length of the other base, 28, and I'm just going to figure out what that number is. So I'm pretty sure those add to 40, and half of 40 is 20. So the length of the midsegment is going to be 20 here. And that is pretty much this lesson. So hopefully this worked for you, and I will catch you later, alligator. Bye.